Buenas noches. Hello, my name is Miguel Alonso. I am the Vice President of Global PLM at DZS. And I'm going to spend the next few minutes giving you our perspectives as to how the network is evolving from traditional GPON deployments to next generation GPON deployments, as well as the readiness and the key elements for allowing for a seamless evolution from the current access speeds to 10, 25, and 50 gigabits per second access speeds. To start, I thought it was probably a good idea to share with you some of the things that have been occurring in our industry for the last 10 years that are simplifying and facilitating the deployment of fiber access networks. When you look at this screen, starting from the left and going to the right, you're all familiar with the fact that over the last 10 to 20 years, there's been move of applications from running in desktops and local compute engines to be running in the cloud, which generates a need for users to have high speeds to access those applications. From a fiber implementations point of view, technologies have been coming to us that have tremendously simplified and lowered the cost of deploying fiber in the access network. Standards have also matured significantly. Today, thanks to the efforts of the Broadband Forum, for example, it is common to deploy interoperable ONTs and OLTs from multiple vendors in the same network. And those standards continue to evolve and mature as it relates to defining what are the next generations of PON implementations that are going to allow for higher speed services. Mobility has become an essential point of access as higher and higher speeds are being made available through mobile networks. With the advent of 4G and 5G, the network capacity needs for carrying all that mobile traffic have also exploded over time. And then last but not least, we live in the era of everything being connected. So every device that is available in the world today has some sort of connection to a broadband access network, be it wired or wireless. It is also, in particular, the trends to mobility and 5G we are observing as a big driver for the implementation of higher speed PON networks. Now, also important to share with you some elements of how the industry is evolving. When one looks at the Omdia reports that show the OLT port shipments of next generation versus current generation PON, current generation being GPON class services, next generation being 10 plus gigabits per second, one observes two very significant trends in this chart. The first one is that after many years in which the number of ports shipped was relatively flat year over year, we're now expecting to see a significant growth of the number of ports, PON ports in general, that are going to be shipped. When you run the numbers starting in 2020, over the next 5 years, that growth could be of as much as 44%. The other remarkable thing on this chart and this study put out by Omdia is the fact that not only XGS-PON is not the future, it's the present, but also there is an expectation that starting in 2022, the shipments of OLT ports for next-gen PON systems is going to eclipse the traditional PON deployments. We are going through that transition in 2021. In 2022, the expectation is that more next-generation PON systems will be shipped than traditional generation. So important to note that while we are speaking here at what seems to be the threshold of the next-generation PON, the reality is that that transition is already happening in front of our eyes. One of the biggest drivers that we have seen for not only the adoption of PON, but also the need for an implementation of higher speed PONs has to do with how mobile networks have been continued to evolve in their use and in their implementation. From an implementation point of view, The majority of the costs of implementing a mobile network are related to transport costs. They awfully dominate the percentage of cost that is associated with the implementation of those networks. In this case, PON has proven itself to be a very cost-effective way of delivering mobile backhaul to cell sites. Very cost-effective way because it allows you to do that using the most fiber-efficient way. As we move to implementation of 5G mobile networks, in which the number of cell sites is going to explode following the concept of densification, the concept of being able to use PON for those deployments is going to be even more important than it was in the past. Not only that, 5G also enables much higher service speeds. So the concept of moving from GPON to XGS-PON is going to be, and it's being already noticed, first in the deployment of mobile backhaul networks. There is yet another element in the mobile network that is contributing significantly to the potential success and adoption of PON implementations for deployment of 5G, and that is the concept of Openrun. When one looks at the studies that exists out there that do comparisons or cost comparisons for implementing traditional radio access networks versus open radio access networks, the first thing that one sees is a significantly lower cost that comes from deploying Openrun networks. This has the effect of enabling more operators to deploy more mobile networks at a lower cost. The chart on the right shows that this advantage of Openrun-based networks is pronouncedly better when one looks at high-density scenarios or even rural deployments. So when you put those things together, the opportunity to deploy lower-cost mobile access networks, the opportunity to significantly reduce the CapEx associated with the implementation of mobile networks using PON technologies, one can see how they all align perfectly with the promise of more bandwidth using 10G plus class PON technologies. When we look at our product portfolio as DZS, we have traditionally offered products to our customers that are very well suited for deployment of access networks, both in fixed wireline as well as mobile access. On the upper hand side of the slide, I show you the different technologies and products that DZS offers to our customers to enable not only the migration from copper to fiber, which is still happening in some parts of the world, but also the very cost-effective deployment of fiber-based networks using PON for residential and business services. In the lower part of the screen, I show you what we are doing with our mobile service provider customers worldwide, offering products that go from right to left, delivering capabilities for fixed wireless access, front haul, mid haul, and back haul. And in this case, we use a variety of technologies. Now, the reason this is relevant is because as of the last 2 years, we have seen a drive for convergence between the broadband access traditional fixed wireline network and the traditional mobile access network. And to illustrate that, I'm going to show you some examples of current DZS customers that are already deploying 10 gigabits per second class fiber-based access networks throughout the world. I'm showing you examples of an innovator in the Americas with TACUS, KCOM in Europe, Etisalat in the Middle East deploying 10 gig point-to-point services, or LGU Plus in Korea deploying, in this case, 10G EPON based services. Likewise, many of our customers that are pure or traditional mobile service providers have been deploying our mobile transport or access equipment for many years. And in some of these cases, we have lived with them through the evolution from GPON to XGS-PON. Going beyond that, even the evolution from packet switch based networks or optical networks to GPON and to XGS-PON. As of today, we've deployed tens of thousands of XGS-PON ports to deliver mobile backhaul services to some of these mobile service operators worldwide. So as I mentioned earlier, the convergence that we hoped would happen maybe 2 years ago is already happening today. It's a convergence of technology that is very real and it's right in front of our eyes. So when we look at overall the driver for mobile cell site transport, and we look at the utilization of fiber-based technologies to deliver that mobile cell site transport, you can see on the chart on the left that when one goes from the 3G to the 5G, so the light blue to the purple to the pink or magenta color on this chart, clearly 4G and 5G mobile cell site transport is predominantly and in a vast majority of cases based on fiber. Our portfolio allows our customers to deploy any technology that they choose: optical transport, packet switching, or passive optical networking. Passive optical networking has the advantage of being extremely fiber efficient and cost effective relative to the other technologies. And that's where many of our service provider customers in the mobile space are deploying today. Another element of convergence that we are observing with our customer base has to be with the extension of services to deliver services, or extension of the network to deliver services to corporate clients. Many of our mobile service provider customers are leveraging the same PON-based, 10G PON-based mobile backhaul network to deliver services to corporate clients. And they do that in one of two modes. One is to deliver traditional services inside the enterprise. The other is to extend the reach of the mobile network inside buildings by deploying or feeding those buildings with PON and then deploying small cells or Wi-Fi 6 solutions inside the building. The same trend is occurring with fixed wireline service providers, where they are using GPON in many cases as a means to deliver high-speed services to residential subscribers, and they're leveraging the same PON access infrastructure to deliver higher capacity 10G PON class services to corporate clients. Now, when one transitions from one technology to another in the telecom industry, we have learned over our many years of experience that the most difficult thing to accomplish is to facilitate a low-cost, low-operational transition from the present mode of operation to the higher speed services mode of operation that, in this case, XGS-PON facilitates. The way we have approached that is by developing technologies that are characterized by three key fundamental elements. The first one has to do with the implementation of what we refer to as any port, any PON, line card, and fixed form factor systems. These are OLTs that have OLT ports that can be individually configured to deliver XGS-PON, GPON, 10 gig active Ethernet, or combo implementations. The combo being providing the opportunity for a service provider to deploy GPON clients and XGS-PON clients on the same fiber infrastructure without having to deploy expensive optical modules outside of the OLT and without having to modify the design of their fiber access network. So the concept of the combo, any port, any PON, access solutions is fundamental to be able to deliver to our service provider customers a seamless migration path from GPON to XGS-PON that can be effected one subscriber at a time, without having to append the network design. The other key element of our approach to enable a seamless transition has to do with how we have approached the design of our OLT systems. We approach it using the concept of a system on a card. This is a future-proof way of enabling uplinks from the OLT directly on the OLT line cards. So the service provider has the option of leveraging centralized and common switching infrastructure and backplanes in the case of chassis-based systems, or they can also choose to extract the traffic from that OLT directly on the line card as to not to burden the traffic through the common switch fabrics. This is very important as we move to 10 gigabits per second, even more important as we move to 25 or 50 gigabits per second, because in those cases, the strains that will be put on the common control switch fabrics would otherwise force significant, very expensive, and very complex switch fabric updates or upgrades in their networks. There is yet a third element that comes with the system on a card, which is the fact that it paves the road for service providers to adopt disaggregated based OLT implementations, even with their existing deployments in the network. And obviously, last but not least, we're also offering our customers, our service provider customers, the ability or the capability to deploy fully disaggregated OLT systems which deliver open, modular, and extensible architectures. So we've been doing GPON for the last 10 plus years. We're just beginning to implement XGS-PON with our customers over the last 12 to 18 months. However, technologies continue to evolve. And we do realize that while the actual practical implementation of higher speed PON-based services, be it 25G or 50G, may be a little bit further out in time given the needs of subscribers, the time is now to be working on the development of those technologies and standards to make sure that we are ready as an industry to effect that transition when the time is right. So from that point of view, we're also very active with the standards community in the development of both 25G PON-based standards as well as 50 gigabits per second PON standards. There's another area of innovation in which we are very actively participating. When you look at the timing and latency requirements for front haul deployments, today they are too strict to be addressed with PON technologies. So we are working with our technology to develop the capabilities for low latency that would be required in those front haul applications. And then last but not least, we're exerting a lot of energy with the complete technology ecosystem to make sure that we are able to influence device roadmaps, for example, with system on a chip providers. But we have the ability to do rapid prototyping of 25 and 50 gig class PON systems so our service provider customers can get ahead of the curve and start toying with the technology. And then last but not least, working with also our service provider customers with our technology ecosystem to do field collaboration to validate those architectures. And to close, just a summary of my presentation today, maybe say that the trends that we have lived in the industry for the last 10 years have taken us where we are in terms of wide adoption of PON-based access technologies. Maybe remind everybody that the time for XGS-PON is not in the future. It's happening now, right in front of our eyes. And while you might not have seen that in your network in particular, many operators around the world are and have been deploying XGS-PON-based technologies for quite some time. The drivers are obviously the insatiable appetite for bandwidth that subscribers have that are putting a strain on both the fixed wireless access as well as the mobile networks, which are converging because the technologies that are used to deliver those services are common. And they're common because PON is this multi-service system that allows you to carry residential, commercial, as well as fixed wireless access and mobile transport. And then last but not least, while we are in the threshold, or at the threshold of the implementation of XGS-PON, and we believe there is a long road in front of us of XGS-PON deployments throughout the world, the time is also now to begin the research and development of the next generation and the next class of 25 and 50 gigabits per second based PON technologies. Thank you very much, and I look forward to our Q&A session.